Okay, so this problem says, and this is from 1.2, it says that E bisects segment DF. So I'm going to start out by drawing my segment. Ooh, that's terrible looking. BF. And it says that it bisects. Bisects has a very specific definition. It says it cuts it exactly in half. So pretending this is actually a straight line, which it is not, I'm going to call that the midpoint. Is it exactly? No, but I'm going to draw it as best I can. And this is point E. And when I bisect something, I create two congruent smaller segments. So DE is congruent to EF. Up here, it says that DE is 2y. So that represents this part right here. And it says that EF is 8y minus 3. So I'm going to label that over here. Okay. It says, draw and label a sketch in the box provided below. Write a geometric equation with justification and use it to find y, dE, well, it says y, the length of dE, the length of EF, and the length of DF. And I'm not going to actually do this for you, but chances are pretty good that you didn't think about how important the word bisect is. Because if it bisects it, it cuts it exactly in half. So doesn't that mean that this right here is the exact same length as that right there? So that's the key to getting started there. And your justification is we're using the definition of bisect. So our justification is definition of bisect. So in a lot of the other things, we may be using the segment addition postulate, but for this, everything that we do hinges on the idea that the length of DE is the same exact length as the length of DE is the same exact length as segment EF. So that's going to be how you get started for that one. I think I forgot to copy the second one that you asked about, but the second one talks about, it says something about a midpoint. Actually, I'll pause the video and add it at the end, so we'll come back to that. T is in the interior of angle RSU. So I'm going to draw angle RSU. So I'm going to say this is R, S has to be the vertex, so this has to be S, and I'm going to have T, oh no, this is U on this side, and it's an angle. These guys go on forever, and it says T is in the interior. I don't know where it is. I'm going to call this T down here. So we're gonna erase this because that looked too smack dab in the middle, and it doesn't say that it's smack dab in the middle. So T is in the interior, and it starts talking about angle RTS. I'm so tired. I'm so sorry. It talks about angle RST. So it looks like I need to connect this, make this array, and call that T. Okay, it says that RST is 38 degrees. So that means this angle right here, and we don't typically trace this, but I'm trying to bring your attention to it. That angle right there is 38 degrees. And it also says that angle TSU, so TSU is 28.6 degrees. So here's T, here's S, here's U. So it's talking about this angle right here being 28.6 degrees. All right, it says draw and label a diagram. Check, I've done that. It says write a geometric equation and use it to find the measure of angle RSU. Well, RSU, did I choose green? Did I choose green? So RSU is the whole big angle. So you need to think about, I need, I can't tell what my colors are, and I'm trying to color code this. So, is this red? You need to think about the little angle plus the little angle and say, okay, the two little angles are equal to the whole big angle. Is this green? All right. I'm not going to do anything more for you, but to write your geometric equation, you have to use like this stuff that I've underlined. So take out little angle and put in the names of the little angles, then substitute in the values of each one of those little angles to determine what the big angle is. So that's the key to that one. Um, This says ray SP bisects angle RST. So I have no idea what kind of angle RST is. It doesn't say in this problem. So I'm going to draw this angle. This is an obtuse angle, right? And I'm going to call this R. S has to be the vertex, and T is over here. And it wouldn't matter if this were R or this were R. That part doesn't matter, but S has to be right there. And it says SP bisects. Well, I'm going to circle the word bisect and remind you that bisect means to cut exactly in half. We can bisect a segment. We can bisect an angle. When we bisect an angle, we're going to get two congruent smaller angles. Okay, so it says ray SP bisects. So I'm going to draw this angle here, and I'm trying to make it look like it's cutting exactly in half. And I'm going to put this marking. This arc mark says that these two angles have the exact same measure, okay? So let's go put some stuff on here. It says RS, oh, by the way, it says that this is P. It says, I need a color. It says that RSP is 3x minus 2. So this side over here that I'm highlighting in purple is 3x minus 2. And can I get a different color? I don't know where all my colors are. Okay. And this one over here, angle PST. So starting at P, going down to S and over to T, this side over here is 9x minus 26. So listen, the key to this is the word bisect. So if you know that this ray cuts this angle exactly in half, then you know that this angle, RSP, is the same measure as this angle, angle PST. So that's the key to that. I'm going to pause the video, grab that other problem that you asked about, and be right back. Okay, so this one says that E is the midpoint. Okay, I'm going to circle the word midpoint and say midpoint means it is exactly in the middle. A midpoint bisects a segment. So E is the midpoint of DF. So I'm going to start out by drawing my segment DF, and E is the midpoint. So it's exactly halfway in the middle. And I'm going to say, all right, if it's exactly in the middle, then that means that DE and EF are the exact same length. This problem says that DE from here to here is 2x plus 4. This is like right in the middle, sorry. And it says that EF is 3x minus 1. You need to draw and label a sketch. I did that for you. Write a geometric equation. So this is very, very similar to the other one. In the other one it said bisect, in this one it says midpoint. Guess what? They're both doing the same thing. They're both creating two congruent segments. So just like the other one, you know that the length of DE is exactly the same length. It's equal to the length of EF. And that's how you're going to get started on that one. All right. Thanks for asking. I'll see you tomorrow. Bye.